Good morning students. Today now we are going to discuss the third application of Gauss law, which is used to find the electric field due to a uniformly charged thin spherical cell. Let here I have made a diagram in which O is the center of a circle and R be the radius of the spherical circle of this spherical cell, and a charge plus q is provided to it, which is uniformly distributed on its surface. Now we have to determine the intensity at 3 points at an external point which is at r distance, at the surface, and inside the cell. Now first I am discussing at an external point. External point. Now let P is the point where the electric field intensity is required, and we know that for a point outside this cell, small r is greater than capital R for a point P. Electric field intensity will be same due to the spherical symmetry. So for calculating the flux emerging out from this small area element dA, d phi E is equals to E dot dA, which will be equal to E dA cos 0, because the electric field intensity and the area vector both are in same direction, so it will be equal to E dA. Now the total flux emerging out from this spherical surface can be calculated by the help of integration. So phi E is equal to integration E dot dA, or E integration dA. Now we know that the surface area of a sphere is 4 pi r square, so it can be written as E into 4 pi r square. Equation number 1. By the Gauss law, we know that phi E is equals to Q upon epsilon naught. And now phi is equals to Q by epsilon naught, and we know that Q can be written as Q is equals to sigma A, where sigma is the surface charge density. So for a sphere it can be written as 4 pi r square sigma. Now from equation 1 and 2, on comparing these we will get E into 4 pi r square is equals to into 4 pi r square is equals to q upon epsilon naught, or E is equals to 1 upon 4 pi epsilon naught q upon r square. This is the formula for the electric field intensity at a point outside the sphere, or this can be written as, if we substitute the value of q from equation from the above result, then we will get E is equals to sigma upon epsilon naught capital R square upon small r square. Now it is the formula for electric field intensity at a point which is outside the sphere. For a point which is at the surface of the sphere, capital R will be equal to small r, and the formula will reduce to E is equals to 1 upon 4 pi epsilon naught q upon capital R square, or sigma upon epsilon naught. So this is the formula for electric field intensity at the surface of a sphere. Now the third situation is at internal point. As at internal point it is not containing any charge, so phi E is equals to E into 4 pi r square is equals to 0, or E equals to 0. This is so because it does not contain any charge inside the cell, or electric field intensity is 0 everywhere inside the charged cell.